Hello class. So today we'll like to look at a few problem set questions. So let's try to get started from number 73. So log of a over log of b is equal to 1000. What is the numerical value of this? Now when you look into the subtraction of the logarithm, we can rewrite that as log of a minus log of b. Entire thing divided by log of b. Now, but the thing is, this is quite nice because log of b divides log of a just like earlier, and then log of b divides log of b itself. So this can be rewritten as log of a over log of b minus log of b divided by log of b. Now the first fraction is in fact equal to 1000, as you can see over here, minus the second fraction is simply equal to 1. So our final answer becomes 999. Alright, let's look into number 74. B is log base 3 of x. Now, in this case, 2 can definitely come out. Or if I were to rewrite this one, this becomes b to the 3 power is equal to log base 3 of x squared. You see, base of b, and then that's the exponent. Now, but the thing is, this, if I were to rewrite this one, this is equal to 2 log base 3 of x. That's b cubed. But we realize that log base 3 of x is equal to b itself, so we can rewrite this one as b cubed is equal to 2b. Now, by bringing 2b onto the other side, we get to realize that b cubed minus 2b, which is equal to 0. Now, if I have to factor this one, we get b, and b squared minus 2 is equal to 0. Now, obviously, we can make the t-chart. We realize b must be equal to 0. That's one of our solution. Second solution is b squared minus 2 is equal to 0. That means b, in fact, is equal to plus or minus square root of 2. So we have 3 answers. Then let's try to put these things into the place of b and then find out the value of x. So if b is equal to 0, then we get log base 3 of x. That should be equal to 0. That means in this case, if I have to rewrite it, then we get 3 to the 0 power is equal to x, which is equal to 1. X has to be equal to 1. That's one solution. Second solution is square root of 2, which is equal to log base 3 of x. Then 3 to the square root of 2 power is equal to x. Alright, third one, negative radical 2 is equal to log base 3 of x. Then here, 3 to the negative radical 2 power must be equal to x. So we have total 3 answers. Alright, let us move on to the next question, number 75. Here we have a proof question, show that the left side is equal to the right side. But I see that the ends has been repeating. And I see the number 100 here, 100 here. So in fact, if I have to rewrite this, each one, we'll get something like this. Log n of log 2 by changing base formula here. Second one becomes 1 over log of n over log of 3. That's how I can rewrite the second denominator. Third denominator would be 1 over log of n divided by log of 4. And this pattern will continue all the way up to 1 over log of n over log of 100. Now, then in this case, we get to realize that all these things can be rewritten as, because 1 divided by the fraction becomes it's simply equal to its reciprocal. So here we get log 2 over log n, plus second one is log of 3 over log of n, plus here we get log of 4 is equal to log over log of n. And this pattern continues just like earlier. over log of 100 over log of n. Now, then, since all of them happen to have a common denominator, we can rewrite this one as log of n. Now, but whenever you add, what do you do with the results? We just have to multiply them. So log base 2 times 3 times 4, and continues all the way up to 100. But 2 times, either 100 multiply all the way down to 2 or all the way down to 1, that's the same story. So I can rewrite this one as log of 100 factorial over log of n. Now, this one looks more and more like what we see over here. So then, what we can do is this now then is equal to 1 over log n over log of 100 factorial. But this can be rewritten as, the bottom portion can be rewritten as 1 over log of base of 100 factorial of n. And that's exactly what we have to show for in the beginning. Alright, let's move on to number 76. Here a sub n is this way, and where n value here matches with n value here, that b becomes this way. Then a sub 2, in other words, 1 over log base 2 of 2013, plus the second one becomes 1 over log base 3 of 2013. Next one is 1 over log base of 2013. And then the last one is 5, so we have 1 over log base 5 of 2013. But this question is similar to the previous question, where I can separate the results and then its base. Then we end up getting 1 over log of 2013 over log of 2. And you get to realize that this will repeat itself one more time. And then same thing will happen here. So 1 over log of 2013 all over log of 4. And then the last one is log of 2013 over log of 5. Now then, same way as before, we can get the reciprocal of each one. And since then, in that case, we will have common denominator, what we can do is we can rewrite it as log of 2013 is the denominator, and the numerator becomes log of 2 plus log of 3 plus log of 4, and then the log of 5. Then this becomes, we just have to multiply these values. Then this becomes 6. And then 6 times 5 is 30. 30 times 4 becomes 120. So we have log of 120 divided by log of 2013. Now, second one. And what we, as you can see, what we have done is that's the B, and then to find C, we have to start from 10 all the way up to 14. Then C, if you have to follow the same procedure, will be log of 10 plus log of 11 plus log of 12 plus log of 13 plus log of 14 all over log of 2013. Now if you combine them together, we'll end up having log of 10 times 11 times dot 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 all the way up to 14 and divide by log of 2013. Now since what we're looking for is b minus c, that is b was log of 120 over log of 2013, as you can see right over here, minus c would have been log of 10 times 11 times 12 times up to 14 all over log of 2013. Now since they have a common denominator, what we can do is you can subtract. But when you subtract, we get to realize that we get to divide here log of 120 over 10 times 11 times 12 times 13 times 14, and then all over log of 2013. Then obviously this 120 can cancel out with the 10 and 12. Then we are left with 11, 13, and 14. So if I were to borrow the calculator quickly, 11 times alright, so as we wait, so here we end up getting 11 times 13 times 14. So that's 2002, so this becomes log of 2002 divided by log of 2013. Oops. And that becomes our answer. Alright, how about this one? So here if I were to rewrite it, this one becomes log of x plus 3 log of y is equal to 1. That's the first equation. Second equation is 2 log of x plus log of y is equal to 1. So one way for us to calculate this one is I can multiply the bottom one by maybe -3. And what happened? I have log of x minus 3 times 2 becomes 6 log of x, so then we end up getting -5 log of x. And -3 multiplies to log of y becomes -3 log of y, but we are given 3 log of y, those two will cancel out. And then at the end here we have 1 minus 3 times 1 becomes -2. So log of x seems to be simply 2 over 5. Now, then since we know the log of x, we need to figure out the log of y. Log of x would have been something over here. If I have to borrow the idea, then 2 times 2 over 5 plus log of y must be equal to 1. Then here we get 4/5 plus log of y equals 1. Then log of y then becomes 1 minus 4 over 5, which is 1/5. And that becomes our answer. Alright, let's look at number 8, or 78. So the given condition is that first common logarithm of x plus y is equal to z. Now this implies here we have 10 to the z power is equal to x plus y. And then we see that's basically what we're looking at here. Second one here is the 10 to the z plus 1 is equal to x squared plus y squared. Alright, then we have to use these two given conditions somehow satisfy this one. So the fact that we are looking at x cubed plus y cubed is equal to a times 10 to the 3z power, and then plus b times 10 to the 2z. Alright, then let's see what happens here. But this can be factored into x plus y times x minus negative xy plus y squared. Now, then here, from the first portion, that portion can be rewritten as this one, x to the z power. But how about the inside portion? That's in fact x plus y, because I want to consider the positive here. Then what we could have done is x squared plus 3x y well, let me just rewrite it in a different way. This one in fact is equal to x plus y squared minus 3xy. But then here we have x plus y is 10 to the z power, so we have 10 to the z power. Here 10 to the z squared minus x here was, oh, now we need to figure out what x times y is. We can figure out x times y is from here, because x plus y squared minus x squared minus y squared becomes 2xy. So therefore xy must be equal to x plus y squared minus x squared minus y squared all over 2. Then minus 3 times xy is equal to, in fact, this way. Then we have x plus y, which is 10 to the z power square, and then minus this portion is x squared plus y squared, which is this portion that you see. So therefore what I can do is 10 to the z plus 1. And then all over 2. So then let's see what happens. Here is equal to 10 to the z power, and then parentheses 10 to the 2z. And then here we end up getting negative 3 over 2, 10 to the 2z, and then plus 3 over 2 10 to the z, and then plus 1, then it becomes times 10. Now then here what we end up getting is this. If I have to simplify, 2z and 2z can be combined here. Then 10 to the z power, and here minus half 10 times 10 to the 2z, and here we end up getting plus 15, because 10 and then 2 becomes 15 times 10 to the z power. When I distribute 10 to the z power to all three terms, then we end up getting negative 1/2 10 to the 3z, and then plus 15 times 10 to the 2z. Then, as you can see by comparison, a is the coefficient of 10 to the 3z, which is equal to right over here, and this becomes b. Now, we are looking for a plus b, so then here, a plus b becomes 14.5. And that's it, and I'll see you later. Bye-bye.